Hi, and welcome to the LLM Engineering in Practice with Streamlit and OpenAI course. I'm thrilled to have you aboard this exciting AI journey. Before we dive in, let me tell you a bit about myself. I'm Peter, a Glasgow Caledonian University graduate with a degree in computing. Throughout my studies, I developed a strong foundation in Java, JavaScript, Python, and SQL, and explored machine learning. This is where my passion for building software solutions and a keen interest in AI really took root. I've been working at 365 Data Science for the past 4 years, where I've been part of the team responsible for developing the very tool you'll be learning about in this course, an AI-powered interview simulator tailored for aspiring data scientists. Mastering large language model, or LLM solutions, is now more critical than ever. According to a survey conducted by the global management consulting firm McKinsey, 72% of organizations have adopted some form of AI in at least one business function, and 65% are regularly using generative AI, up from just 33% in 2023. This significant increase highlights a growing reliance on AI technologies across various sectors and regions. Looking ahead, the LLM market is set for explosive growth. According to Dimension Market Research, the market size is projected to soar from $6.4 billion in 2024 to an astonishing $140.8 billion by 2033. This expansion is driven by the increasing adoption of LLMs across diverse industries, such as healthcare, finance, and customer service. These models are revolutionizing automation, data analysis, and customer interaction. Here at 365 Data Science, we've also harnessed the power of the large models to create a solution called ACE Interview. This tool is essentially an interview simulator that leverages LLM technology to conduct realistic HR and technical interviews while providing personalized feedback. The ACE Interview tool is now available on our platform. I encourage you to give it a try. I'm excited to tell you that in this course, we'll walk you through the development of the ACE Interview tool itself, giving you a full view of the process from initial design to final implementation, and sharing the challenges and mistakes we faced along the way. Additionally, you'll gain deep insights into the theoretical and technical aspects of building your own application, which is essential for planning your ideas and communicating them effectively with stakeholders. By the end of this course, you'll have a fully functional prototype to showcase in your portfolio, demonstrating your ability to design and implement a powerful LLM application. Throughout this journey, you'll acquire skills in prompt engineering, memory management, cost optimization, secure data handling, robust security implementation, performance scalability, and managing real-world issues like hallucinations and prompt injections. With these skills, you'll be confidently prepared to tackle your own LLM projects from start to finish. I'm excited to guide you through this process and explore these new horizons together. Welcome back. In this lesson, I'll walk you through the game plan for the course. Let's get started. We'll kick things off by showing you exactly how we brought our idea to life, from the initial planning stage to the development. To simplify this process, we've divided the course into sections corresponding to each development stage. We begin with the planning stage. Here, you'll gain an understanding of the foundational decisions you'll need to make, like whether to host an LLM yourself or use an API. We'll also explore different model options and help you navigate the complexities of tokens and pricing. We'll then wrap up the planning phase by exploring the development of activity diagrams and their role in effectively mapping your project. Once we've got our plan in place, we'll move on to creating a prototype. This is where things get hands-on. We'll begin by learning how to configure the model settings for the GPT model family. Then, we'll dive into the art of prompt engineering. With this foundation, we can utilize Streamlit, a powerful tool for creating shareable web apps from Python scripts, to build a functional prototype. This prototype will serve as a mock version of the ACE Interview app, highlighting its core functionalities. By the end of this section, You'll have a working prototype uploaded to your GitHub repository and deployed using Streamlit Community Cloud, ready for you to share with others. In the final section, we'll transition into advanced development, exploring the structure and mechanics of the final product and demonstrating how various LLM components work together to execute multiple tasks. We'll also discuss the systems we developed to address model inconsistencies. As your app gains traction, we'll explore more complex challenges, such as handling hallucinations, mitigating prompt injections, and optimizing pricing and scalability. Whether you aim to build a practical tool or boost your professional skill set, this course will equip you with the knowledge and experience you need to succeed. So, let's get started. Let's start this lesson by exploring the core concept behind our tool. At the heart of our vision was creating an interactive experience powered by a large language model capable of conducting interviews that seem remarkably real. Picture yourself in an interview for a data science position where the simulator conducts the process with stunning accuracy, just like an HR executive would. The application uses your information to ask the same questions you would encounter in an actual interview, making the experience as authentic and tailored as possible. We recognized, however, that not all interviews are identical, especially in the vast and varied field of data science, which includes numerous distinct positions. It became clear that to simulate the diversity of real-world interviews, the application must allow users to specify the exact position they're aiming for. We also considered the distinct interview methodologies used by different companies, each with its own set of questions and approaches. To address this, we decided that users should be able to select the company they aspire to work for, adding a layer of realism to the simulation. Alright, let me summarize what we've laid out so far. The requirements list looks as follows. The application must be capable of conducting realistic job interview simulations. Users should be able to tailor their interview preparation by selecting the specific position and company they're targeting. To add another point to our requirements, users can provide information, such as their previous experience and skills, to receive a more personalized interview. It all looks good so far. But while these requirements set a solid foundation for our tool, it quickly became apparent that they weren't exhaustive. To effectively aid interview preparation, we realized it was crucial to assess users and provide insightful feedback, highlighting their strengths and identifying areas for improvement. To bring this vision to life, our approach was to create a nuanced scoring system that could accurately reflect a user's proficiency across various criteria. But during our initial research, it became clear that adding the feedback feature alone might not set us apart from existing alternatives in the market. Several tools already offer interview simulations and feedback, so we knew we had to go further and implement a functionality that puts us one step forward. We revisited the drawing board, dissecting the structure of the data science interview process. Data science interviews typically last 1 to 4 rounds and fall into 2 main categories: HR and technical interviews. HR interviews are a preliminary step in testing candidates' suitability for the company culture, team, and the specific role they're applying for. These interviews are typically less about assessing technical expertise and more about understanding a candidate's work ethic, communication skills, and overall fit. The interviewee might receive questions from categories like behavioral, technical knowledge, situational, brain teasers, or theoretical categories. Technical interviews, on the other hand, are designed to assess the candidate's problem-solving abilities. These interviews typically test coding skills through take-home assignments or on-the-spot tasks. Common interview topics cover technical expertise, case studies, coding, and database skills. We opted to incorporate both interview types into our application, offering a complete rehearsal of the entire data science interview process rather than just simulating individual scenarios. But how does the model come up with relevant interview questions? Our application will feature a comprehensive database storing real-life questions for both HR and technical interviews. These questions are specifically tailored for each position and company that the user selects. With this database, the model can draw inspiration to generate new and unique questions, ensuring a more personalized and realistic interview experience. Alright, everyone. Documenting requirements early establishes a solid foundation for the project, ensuring all team members, from developers to designers, understand the objectives and have a clear basis to explore solutions. Discussing these requirements with stakeholders guarantees the set milestones are achievable. It's easy to get swept up in the excitement of a new idea, which can lead to overestimating what can be done within the given constraints. Now that we've discussed the specifics of our tool, get ready for the next section, where we'll dive into the technical aspects of the project and start bringing this idea to life. See you there.